Comparative analysis of electricity consumption at home through a 실내스퀘어 prospective. 현홍채 나무만 배시케르신 동일신. 성관 University of Korea. Machine learning is a state-of-art subject project of artificial intelligence that have been evolved for finding large-scale intelligent analytics in the distributed computing environment. In this paper, we perform comparative analytics onto datasets collected for the electricity usage of home based on a k-means clustering algorithm using comparison to silhouette score with a ratio of A per 1 dataset. The performance evaluation shows that the comparison index is similar numbers of silhouette score even if dataset is smaller than before. Keyword k-means clustering, machine learning, unsupervised learning, silhouette score. Machine learning is an analyzing mechanism that fetches and identifies the matching patterns from the existing data for new result formations. This paper discusses comparative analytics related to unsupervised learning algorithms, at which we compare the k-means clustering result with a ratio of half dataset to silhouette score result. We performed analysis and came to conclusion that David's burden index is not working smoothly in the scikit learning. So performed a check analysis for Karin's-Karaba's index and the silhouette score along with and David's burden index and compared results to each of them so to run that when we reduce the dataset to a mentioned proportion, the resultant dataset shows half score than the traditional dataset score. Previous works. Machine learning is a field of artificial intelligence that is used to develop algorithms and techniques that enable computer to run. It is used to train the computer to distinguish whether emails received are spam or not, and there are various applications such as data classification, associated role identification, and characters recognition, which comply to the standard machine learning perspectives. It includes a series of processes in which a computer finds its own patterns, creates a new classification systems, analyze the data, and produce meaningful results. The successful prediction occurs with the increase in probability and decreases in the error issues. Machine learning enables sort out the issues with variable iterative learning. Reference to. Among them, the supervised learning is highly related to summarizing the learning method for reinforcement mechanisms. Clustering is a process of mining the dataset by defining a cluster of data that considers the characteristic of input and finds a representative method to point out the data groups. In this way, a cluster is a group of relevant data elements with similar characteristics. If the functions are not the same, the ingredients belong to contrast clusters. Number 3. Clustering is unsupervised learning without accuracy in answers. In the same way, the objects having same information are grouped together for similar elements. However, the classification is way related to supervised learning. When you perform classification operations, the system will run to predict the dependent variables y with the independent variables x of the data. Number 4. Scikit-learn is a machine learning platform in the middle range of superficial broad Python module. This package, high-level languages can use easily high-level documentations and proper API suggested. Using BSD license as academic or commercially used. Source code documentation is downloaded from website. Number 10. Supervised learning. Unsupervised learning is many problems is inserted in the scikit-learn. Generalized models, linear and quadratic recruitment analysis, kernel rigid regression, support vector machine, stochastic gradient descent models solution also inserted in the scikit-learn. Proposed approach. K-means algorithm is one of the clustering methods for divided. Divided is giving the data among the many partitions. For example, the received data object n divided data is input data divided k. Data each group consists in of cluster. Below equation is the K-means algorithms when cluster consists of algorithms using cost function use it. Number 11. In other words, one of the data object divided by the k group. Currently divided similarity is dissimilarity with reducing the cost function about it. And from this theory, each object similarity increase. Different group similarity will decrease. 12. K-means algorithm is each centroid and each group in each group's data object times summations. From this function result, the data object group updated clustering progressed. Reference 5. Serial score is the easy way to in data each data cluster in data's definition on each data is in a clustered inner and data's definition bi serial score si is equal to calculate that si equal max ai bi per bi minus ai. From this calculate si is equal to the function si is close to 1 is the dataset I is the correct cluster to each thing. Close to -1 cannot distribute cluster is distributed. From this paper, machine using the machine learning library scikit-learn in the household power consumption clustering. Household power consumption from the dataset downloaded from the University of California Irvine Machine Learning Dataset Repository. Number 8. And then use it. Data is via delimiter is divided. Global active power, global reactive power, voltage, global intensity is divided. Global active power and the global reactive power XY axis is experimented. Python library is Anaconda 3 K-means algorithms. Key point is using data K clusters, reduce clusters distances. K-means algorithms input data put the levels. Figure 1 is the before check current scalable index and serial score executive K-means clustering result. Figure 1 to Figure 11 are A per 1 dataset K-means clustering result for household power consumption from UC Irvine repository and then reduce the dataset A per 1 times from original UC Irvine machine learning data repository. Figure 1, A per 1 dataset cluster K equal 1. A per 1 dataset K equal 2. A per 1 dataset K equal 3. A per 1 dataset K equal 4. A per 1 dataset cluster K equal 5. A per 1 dataset cluster K equal 6. Serial score according to the change of cluster number. Dataset serial score according to the change of cluster. From K-means algorithms, calculate proper cluster thing is very important. From the data, estimate the serial score. The result is K equals 7. Each cluster centroid and data prices. Serial score is 0.799 is the optimal score. Even if dataset is so small, but the A per 1 dataset K equals 7. Each cluster centroid and data prices. Serial score is 0.810 is the optimal score. From this K-means cluster K equals 7, all dataset A per 1 dataset, each group's centroid and each centroid distance will be an optimal value. From this result, the dataset is decreased, but the K-means clustering's class vector space. Each optimal cluster is the same situation with before. Original dataset household power consumption rate via clustering. Conclusions. From the paper, household power consumption via K-means clustering. Use the library which is scikit-learn Anaconda 3 open source library can easily follow it, and because using the BSD license, real-worlds don't have difficulties to do that. From this result, even if reduce the dataset A per 1, but the serial score and all the clustering result is the same with before, but the population will increase, it can show the clearer result for the classification and vector spaces. Large dataset to small dataset is clear to show to the specific result for the serial score, but opposite side is not clearly allowed. Because 4-dimension vector dataset from the experiment reduce the estimate time if received huge dataset from analysis. Reference.